Alright, so we are going to solve this trigonometric equation, and we are going to use a trig identity to actually simplify this equation and then go ahead and solve. Mind you that x is the angle and it is in radiant measure, so we want the value for x between 0 and 2 pi. So let's go through that. So first, sine squared 2x. So let's rewrite what 2 sine x cos x is. This is sine of 2x. So right hand side we still have sine squared 2x. That's not going to change. Sorry, left hand side. The right hand side 2 sine x cos x is sine 2x according to the double angle identity. And now we're going to bring everything to one side. We have sine squared x, sine squared 2x minus sine 2x, set that equal to 0. And in here we can factor sine 2x out because there are two of them, the first term. So we have sine 2x minus 1, set that equal to 0. And in this case we use a zero product rule. So two options we have. One is sine 2x, set that equal to 0, or sine 2x minus 1 is equal to 0. And for each of these we have to go through and solve. In this case 2x equations, we're going to solve each one of them separately. Equation, first one, sine of 2x equal to 0. Now before that I want to quickly sketch the graph of sine of x, and notice that here we have a 0, pi, 2 pi. These are the x-intercepts or the solution to the equation or to the function sine of x. Okay, so now we know that 2x, the first one would be 0, so that means the first angle, it is 0. That's the first angle. The next one is that 2x, so that's number 1. The second solution to that is 2x must be equal to pi, which is right here, which is right there. So first one was pi, 0, pi, and we're going to deal with the 2 pi as well, but now we are at pi. So if 2x equal to pi, that means x has to be pi over 2. So this is the second angle. The third angle is we're going to deal with is 2 pi. So we're going to set that up again, and that will be 2x equals to 2 pi. Now, so x equals to pi, so that's the third solution on top of that. Okay, and then the fourth one is when we know we have to do 2x equals to pi plus 2 pi, because the period of the 2x function is actually right here, sine of 2x, the period of this function is actually pi, because the double angle makes the total period to be half of the original 2 pi, and that's what you will get. And when you solve this, x will be equal to 3 pi over 2. Okay, that's it. And now we got 4 for the first equation. Now we're going to go ahead and solve for the second equation, which is sine of 2x minus 1. Now we are going to deal with sine 2x minus 1. So here it is. Let's go ahead and solve again. Sine of 2x equals to 1. Now in this case, so we want to see that. So let's just sketch this graph again. I'm going to redraw the function graph, but this time I'm going to exaggerate it so that you can see that. So here is the value function is 1, and that happens at pi over 2, and here is negative 1, and that happens right here, that happens at 3 pi over 2 for the sine function. So these are the values right here, pi over 2, 3 pi over 2, and this is what we get, negative 1 and 1. Okay, so we're going to go ahead and solve that. So we have 2x must equal to pi over 2, that's the first one because it's equal to 1. So 2x has to be equal to pi over 2. That's the ratio. X equals to pi over 4. So that's the first solution to that one. Next solution is when we have 2x is equal to, now we have pi over 2, but then we also have to add another 2 pi to it. Now we have to set up 2x equal to pi over 2 plus this time 2 pi. Now you might wonder why we're adding 2 pi. The range is actually 0 to 2 pi, but 0 to 2 pi is for this function sine 2x basically at the end. And this function has a period. The period of the sine 2x function is, the period of that is pi, is half of the original. So it actually will end up being within the 0 and 2 pi, and that's why you have to set that up, because it's a cyclical, so we have to go through the full period. So what is x? And x, when you do the math on this one, will end up getting 5 pi over 4. Excellent. So how many solutions altogether we have? So at the end we have 6 solutions. So we have 1, 2, 3, 4, 5, and 6.